Absheni, Dumelang Sanbonani Goeiedag. Welcome to the Agricultural Engineering Podcast. This podcast covers all aspects of agricultural engineering. It is produced by the South African Institute of Agricultural Engineers. The series of episodes has been funded by the Royal Academy of Engineering. We encourage you to tune in and explore the exciting world of agricultural engineering with us. My name is Damien Mukansi, and I'm your host for today's episode. This episode will explore the role of agricultural engineers in research. We are joined today by Dr. Maharaj, a recent graduate at the University of KwaZulu-Natal, who is currently an engineer at Ground Truth. Welcome, Dr. Maharaj.
Hello, Damien, and hi to the SAI audience.
So, Dr. Maharaj, can you please share with us about your journey in becoming an agricultural engineer, emphasizing on your choice of area of specialization?
Before I start, I just want to say thanks for having me on the podcast today, and I'm really excited to talk about my research, which was essentially focused on improving event-based design flood estimation in South Africa. But before that, what actually drew me to agricultural engineering was its interdisciplinary nature. So I've always cared about the environment, and this field combined science and engineering with the water and earth resources. So for me, it was a perfect fit. And throughout my studies, I've realized the crucial role that agricultural engineers play, from ensuring food and security in the water sector to mitigating climate risks. So I think in terms of my area of specialization, I particularly enjoyed hydrology and the different aspects that come into play when doing hydrological modeling. So you have to understand the physical earth systems as well as the complicated maths and statistics. So for me, it was a no-brainer. Just to speak a little bit about my life now, I'm currently an engineer at Ground Truth, which is a science and engineering consulting company. But we also have a very strong focus on interdisciplinary work and the environment. And I closely work with engineers and scientists from the four main divisions, which are rivers, wetlands, biodiversity, and engineering. So I'm very fortunate enough to be able to work with other agricultural engineers and be able to implement and put the knowledge into practice now while I'm working. And I think it's also important to highlight that there are direct links between what we studied at university and what I'm seeing in the working world.
Thank you, man. I think one of the things that we appreciate definitely as a country, is the need for proper research so that practitioners can take the right decisions out there in industry. You recently graduated the PhD in agricultural engineering. Can you please take us through your PhD study? So what the topic was, what the study aimed to address, which methods did you employ, and the main findings from your study?
So I'll first give a layman or a simple term explanation of the study. So in essence, what we looked at doing was improving the accuracy of flood predictions when using a model called the SCS curve number model, which is a common tool used in South Africa and internationally. And what we did in my PhD was develop a framework to understand the inherent uncertainty in the outputs from this model. And this was important because it allows us to get a better account for potential variations in flood events. So for some background, my postgraduate research was on design flood estimation, which essentially associates the magnitude of a flood to a level of risk. So design flood estimation is important because we use rainfall to estimate floods in South Africa. It's a very common practice because of the lack of observed stream flow data. And my PhD was titled The Improved Performance and Uncertainty Estimation in Design Flood Estimation Models Used in South Africa, using the SCS curve number model as a case study. So I think I gave some background now. So even if you're not a hydrological expert, you should understand a little bit more about the study. And in terms of the aims of the research were firstly to assess and improve the performance of the SCS curve number model for design flood estimation in South Africa. And the second aim was to concurrently develop a framework for uncertainty estimation of event-based design flood estimation models. So to achieve this and while I was performing the study, I essentially had to use a range of different methods, from delineating catchments to cleaning hydrological data, running event and continuous simulation models, as well as a broad range of statistical tools and tests. And these have been very important because I realized that these techniques are regularly applied in different spaces. And the key findings from my study was that it is better to parameterize hydrological models using local observed data, so data for your catchment of interest, and that it is also better to use a stochastic model to get a better understanding of the uncertainty of model outputs. Because in essence, what we did was run a model thousands of times instead of one single time. And we got a broad range of answers that will most likely be more representative than a single value.
Thank you for that. I mean, I'm quite sure that, you know, some of our listeners are wondering, how can your research contribute to addressing water challenges in South Africa and globally? What's your take on this?
I think that's a very interesting question, and we've fortunate, well, not fortunate, but we recording this podcast in a time where there's quite a few floods happening at the moment. So in the past, flood events were not very common, but this year, for example, there have been floods throughout the world. So in Afghanistan, Germany, South Africa, in KZN, we had the Margate floods at the start of the year, and last week there were floods in Cape Town, Bangladesh, the United States of America, and India. And I think my research is significant because of the decline in monitoring stations and the increasing reliance on social media, which can sometimes raise questions about scientific data. So the findings from my study can help us quantify the uncertainty in flood predictions, which make them more reliable. And the framework that we developed for uncertainty quantification can be applied to improve other flood estimation models, so not only the model that we used. And one of the more exciting aspects of my research is the practical application, because more accurate flood estimation models can help us design sturdier bridges, better roads and buildings, particularly in flood-prone areas. And this translates to safer infrastructure and reduced risks during floods. And I think in general, these models can be used to create more precise floodplain maps, which in essence inform your land use decisions and can also help communities prepare for potential flooding in the future.
And as you roughly say, Dr. Maharaj, not just only as it relates to flooding, but I'm sure for various governments internationally that are out there, one always wants to ensure that they're not over designing, they're not overspending. And so, this accurate estimation of design floods is quite crucial to prevent also things such as over designs of your hydraulic structures. And agricultural engineers, they tend to work in a very interdisciplinary setup. How has collaboration played a role in your research, and how has it enriched your work?
I think, Damien, firstly, I must agree with you that these sort of tools that we use can help us reduce the over and under design. And I think, obviously, with under design, if you reduce that, it's good because you can reduce significant cost implications associated with disasters. And the over design is also linked to significant cost impacts. And I think, as you rightly said, that we do work in interdisciplinary teams. So to understand those cost implications, you find yourself working with economists and a range of different people. And at its core, agricultural engineering is all about teamwork. So, for example, during my master's study, I primarily collaborated with hydrologists. And even in our undergraduate training, we were equipped to work effectively in interdisciplinary teams. So I think now, while I'm at Ground Truth, earlier on, I spoke about the different teams that we worked with, but I work with civil engineers, ecologists, geologists, and a range of different people. But the training that we received as agricultural engineers allows me to tackle these complex problems from a different perspective and together with diverse teams. So, for instance, I worked on a project for the International Water Management Institute, and we collaborated with scientists and engineers from various institutions and backgrounds and different countries. But I was able to apply hydraulic modeling techniques and perform habitat analysis and also data analysis from drones, and able to communicate that to these different people because I had a good understanding of how we need to work together with different people and understand their perspective and then communicate effectively to the different people. Because I think there's a common misconception that engineers like to work in silos and we have a very rigid way of thinking. And it's common to hear people say that engineers don't play well with others and we generally only like to work with engineers. But I think that's what it is. It is a misconception because I found that, especially with the challenges we face, so for example, with climate change, engineers are not experts at climate change, but when you're doing designs and you're doing work, you have to incorporate that into your thinking because climate change poses a significant threat to water resources and agricultural production. And I think agricultural engineers are at the forefront of developing solutions to mitigate these challenges, but we have to work with other people to mitigate these challenges and design good solutions. So we can design water harvesting systems to capture rainwater to help during drought, and we can also help to develop and promote sustainable land management practices that minimize soil erosion and promote water retention. But the only way that we can do it successfully is by working with other disciplines. And I think, with that being said, most of the agricultural engineers that I met and that I interact with do work with other people. And I think that's one of the important things that we take away from our training, our undergraduate training, is that it is an interdisciplinary field. And I think now we're also moving into that transdisciplinary sort of thinking. So where you're not just interacting with other disciplines, but you're coming together and you're co-creating solutions. So yeah, Damien, you brought up a very good point, and I think it's good that we can speak about that now.
Yeah, this whole thing of, working with other discipline, it's quite important, and I sometimes feel like, that's one thing that our listeners should have at the back of their mind, that our designs are solely meant for people, and people interact with the environment in various ways. So I think it's one of those crucial and most important parts about a design. And I'm sure, Dr. Maharaj, what's your view on this whole concept of designing solutions that are people-centered? Because at the end of the day, if you're designing a stormwater to deal with flooding, the stormwater still needs to be managed. So what's your take, on having the end user when one is making a design?
I think that's a very important way to look at design. So human-centered design is very important because there's been cases where you see somebody comes up with a bright idea and they develop the solution and they think it would work. And when you go out there and you speak to the communities, they're not very open to it because it doesn't fit in with their lifestyle, it doesn't fit in with their cultural practices. So something that I've recently started learning about with Dr. Mark Graham and Dr. Jim Taylor at Roundtrip is the concept of citizen science and learning labs and co-creating solutions. So whenever we go out and we're working on a project, we always think about the people and how they would take whatever we proposing to them and whether it would be integrated into their lives. And I think, Damien, even when doing my PhD, it's something we had to consider because the SCS curve number model is a popular model that people use. But if we went in there and we changed it too much or made it too difficult to use, then the entire study would not be beneficial because practitioners and researchers would not be open to it. So I think wherever you are, if you're in academia, if you're in industry, you need to consider people and you need to consider who you're designing something for or who's going to use the product. And I think that's when you can make an impact, a positive impact.
The whole designs which are orientated to people is just probably one of the challenges that your research needed to consider. I mean, in every hydrological conference that I've attended, there's always a pending issue, the issue of data. And if that data is available, the reliability of that data, what are some of the challenges that you can highlight that you faced in your PhD studies, and how did you overcome them?
Yeah, so in the hydrology sector, the issue of data quality and quantity, it runs very deeply. And I think it's a problem that a lot of the students, postgraduate students particularly face. And it's due to the decline in the monitoring network, but also just access to data. But I think there is some positives. So with remotely sensed data, so using satellites and drones, people are able to collect data in near real time. And then there's also citizen science data as well. So I haven't seen it in South Africa, but I've seen in other countries that people now collect rainfall data, and that's used to calibrate models. So that's one of the key challenges was obviously data quality and quantity. But I actually registered for my PhD when it was the COVID-19 pandemic, and then went through the 2022 KZN floods and the social unrest that we also had in KZN. But despite all of these challenges, I was fortunate enough to have incredible support from Prof. Jeff Smithers and the entire Center for Water Resources Research at UKZN. And later on, when I was finishing up my PhD, also with the Ground Truth team. But apart from that, it's just the support from colleagues at UKZN. While you are there, people are always asking you how you're doing and whereabouts you are with your research. And I think it's that sort of motivation that keeps you going. And then on a personal side, obviously family support helped me get through some of the challenges. Obviously most of it was not linked to the research directly. So COVID-19, floods, social unrest and all of that was not directly linked to the research. But what I took away from it is that having a supportive environment makes a very huge difference when you're doing your postgraduate research. And along with the strong foundation I received during my undergraduate studies, also helped me focus my research skills much better. So the graduate attributes that you get as an undergraduate student at UKZN are very strong, and it really truly equipped me to handle the demands of research. So I know when you in the research space, you hear a lot about PhD students facing burnout and they're struggling. And I know, Damien, you're also currently working on your PhD, so you're probably familiar with these type of terms. Where people, it's almost taboo to ask a PhD student how are they doing and when they're going to finish. But I think with the support and training that we got, that was key to me finishing despite all of the other challenges.
Despite those challenges that you raise in your PhD studies, one can see that there's really some memories that you developed in UKZN with other team members, other staff members. What are some of the memorable experience from your time as a PhD student?
My PhD journey was filled with many great moments. So, for example, I served as the chair of the Hydrators Club, which is a postgraduate student club at the Center for Water Resources Research. And I also got the opportunity to tutor and lecture many undergraduate modules. And I really enjoyed learning from the perspective of undergraduate students. And I was also fortunate enough to see how these students transitioned back from studying and learning online to going back to in-person learning. And then apart from that, I was also fortunate enough to present my research at conferences and workshops throughout South Africa and also internationally. So that was another highlight for me. So I had the privilege of interacting with renowned hydrological experts like Prof. Richard Hawkins, Prof. Roland Schulze, Prof. Keith Bevan, Prof. Victor Pons. And at the international conference that I attended, I had the opportunity to go to Berlin and present my work at the IUGG conference in 2023. And yeah, I think just being able to go out there and deliver presentations, it helped me build my character. So personal, professional development was also something that was a big highlight for me. And these experiences also helped me realize that the future of agricultural engineering is brimming with exciting possibilities. Because when you go out there and you see that there's big data and machine learning, and it's actually revolutionizing the field of both hydrology and agricultural engineering. We are now able to analyze vast data sets on weather patterns, soil moisture, crop health, and techniques to optimize irrigation practices and improve water use efficiency. So I think just being out there and being a sponge, like Prof. Smithers says, was a highlight for me as well, just to see where agricultural engineering is going and what the future holds for the fraternity.
Dr. Maharaj, we have decided to come up with this podcast, to share more about agricultural engineering. But even despite that, I think one of the aims of the podcast is to share knowledge. Because if knowledge is not available, so knowledge is acquired but not made available, that knowledge is not useful knowledge. So I'm sure you spent good X amount of time doing your PhD studies. How do you plan to disseminate your research? And if already by this time there is work that you've already disseminated, which platforms did you disseminate the knowledge in, and how can our listeners get hold of this very valuable information that you spent a good amount of time doing your research on?
Yeah, I agree with you. I think it doesn't make sense to do research and have it kept on a desktop or printed and kept on a shelf in a library. And globally, we've seen the trends move towards open source code and open data. So I've published some of my research findings in the SANCOLD conference proceedings. My theses are available on the UKZN research space. And then I also have papers from my PhD in press with the Hydrological Sciences Journal. But listeners can also feel free to reach out to me directly via email or LinkedIn if they'd like more information. And in general, just in terms of sharing information and tools, there's an exciting project happening at the moment, which comes from the National Flood Studies Program, which was funded by the Royal Academy of Engineering. And we actually build in tools based on all of the effort and research that went into updating the design flood estimation models in South Africa. So soon there will be a set of open source tools going out to use some of the new event-based models, and there'll also be a user guide going out along with those tools. So I think that's also something exciting because we're transforming research products that can be used in industry.
I also, saw you in on LinkedIn. I think there should have been a webinar or a seminar that you hosted where you were sharing some of work related to your studies. Can you take us through that as well?
Yeah, so I was fortunate enough to be invited by the British Hydrological Society to do a presentation on my PhD research earlier this year. So that was quite interesting for me because they obviously a big international organization, and it was I got quite some good feedback from there, and it was also good to hear that the work that we're doing in South Africa can keep up to the international level, and we're doing work that's relevant not only in South Africa but also internationally. So that webinar is also recorded and it's on the BHS website as well if needed.
You also spoke about at some point you were in Benin attending an international conference, and I'm sure there's a listener who is young, still in high school, hearing that, oh my word, this guy just went overseas to present. Take us through your experience. How did you find Benin? And was this your first time out of the country, or was this something that you used to? Just take us through that.
It was my first time going to Berlin. So going to Germany was quite exciting. And being in Europe, interacting with people. When you're a student, you read names on textbooks and you read papers and you always see these names. So for me, going out there, I think for me, I was a bit starstruck. So getting to see all of these international researchers, basically superstars of hydrology, and getting to talk to them and them coming and up to us and asking us questions about the work we're doing. And that was a very exciting experience for me. And I think that came along with obviously doing the PhD. And there's a lot that goes into getting accepted to present at an international conference, but I think it was worth it. And just being there personally, I grew quite a bit because you get to see different cultures and how the people operate, but also professionally, you can see how the different research institutes from other countries operate. So people from first world countries to third world countries and the things that they go through just to be out there, that was quite inspiring for me to see.
What's your advice for, a learner who wants to pursue a career in agricultural engineering, or somebody that's already in the university space, maybe studying agricultural engineering or hydrology, thinking about specializing in hydrological related studies? What's your advice for them?
So, Damien, I'll try and be a bit unbiased here, but I'm sure you know agricultural engineers are very passionate and we punt very strongly for our field. But I think for students that are interested in agricultural engineering, and especially those considering specializing in the area of hydrology, I think the most important quality that they need to have is being passionate and resilient. Because we, as I said earlier, agricultural engineers are on the forefront of some very pressing challenges. So food security, water security, agriculture. And I think if you're passionate about agriculture, water, and the land and water connection, as well as energy, then being an agricultural engineer is a great choice. And then obviously specializing in hydrology, that's an option. And I think for me, I focused on hydrological modeling, but there are also other exciting areas that you can specialize in the water industry. So, for example, you've got groundwater, you've got water quality, and I've seen socio hydrology is picking up currently. So I think that field basically specializes in exploring the social aspects of water management. So I think agricultural engineering and water engineering are constantly evolving. And, now that I've been in the consulting world for a year, I've seen that at Ground Truth, there's citizen science, which is very strong and it's also linked to water. And, you can learn about the state of rivers and water quality and all of that, which is quite important. And I think it's something that you wouldn't think about if you are studying agricultural engineering when you're doing maths and physics and you wonder what's actually happening. So I think if you're a first year student, a second year student, you have to be passionate and resilient and continue. And I think even if you are a graduate, you have to still be passionate and resilient and push through and get to what you want to do and what you want to enjoy. And when you speak about my area of specialty, I think there's a lot of water challenges in South Africa, but with that, there's a lot of opportunities as well. So I think it's common knowledge that we face several challenges, including water scarcity, aging infrastructure, and pollution. But I think with all of these challenges, there's opportunities for agricultural engineers because we play a very crucial role in developing and designing water systems and also implementing innovative solutions to overcome these challenges. And I think just to speak on a few things, there's growing focus on wastewater treatment, rainwater harvesting, grey water reuse, nature-based solutions. And I think those are the areas where agricultural engineers can offer valuable expertise in the future. So if you're a young student, if you're still in school and if you're listening to this, I think it's a great field to be in and it's evolving all the time. And yeah, it's a great choice. So personally, if I had to go back, I wouldn't pick any other degree. That should sum it up quite nicely.
I'm a listener, and I'm young. I'm still very much in high school, but I've been hearing you say a lot about citizen science. What is citizen science, and do I have to wait really to finish matric to participate in citizen science?
Yeah, that's actually a good question. And while sitting here and talking to you, I'm looking up at one of the pictures on the wall here at Ground Truth, and it's a picture of a little kid. He must be about 4 or 5 years old, and he's doing a mini SAS assessment. So mini SAS is basically a citizen science tool that is used to monitor water quality in rivers and streams. So you don't need to finish school, you don't need to have a degree, you don't need to be a fixed age. Citizen science puts the tools into the hands of the people, and I've seen the benefit where you can collect real-time data, and it's not only about water quality. So when we had the floods in KZN a few years back, citizen science came in very strongly because there's people that have early warning systems. So they were able to save their community because of these citizen science tools. And I think it's growing very quickly and putting the power of knowledge into the people. That's where the true beauty of engineering and science lies. Because there's not enough engineers and scientists out there to fix all of the problems. But when you equip citizen scientists to do the work, there's papers published on it where you can see that you actually get valuable, good quality, quantitative and qualitative data that can be used to make important decisions. And I think it's good to see in KZN and in South Africa that it's picking up momentum. So Ground Truth works closely with the EnviroChamps and Amgeni Water and a whole range of different institutions, DUCT, for example, and there's a range of citizen scientists out there. And I think if you're interested in it, Damien, you can go on the Minisas website and you'll see all of those data points are collected by ordinary people, not experts in the field.
I think, yeah, that's a bit informative, and I think it's something that our listeners can take to say they too can participate in shaping the modern day society with science. How can people reach you if they have questions about what you do or if they have a need for collaboration purposes?
Yeah, so I think the easiest way to connect with me would be via LinkedIn. So my profile is my name, so Dr Maharaj, and I'm getting quite active on LinkedIn. So if you connect with me, you can drop me a message, and if needed, we can exchange email addresses or cell phone numbers, and I can answer any questions you have, and maybe I can also ask you questions, and we can work together. And if you're interested in potential collaborations, yeah, you can also reach out via LinkedIn and I'll definitely respond to you. Damien, like you said earlier on as well, it's an interdisciplinary nature of work that agricultural engineers do that's quite exciting. So I think even if you aren't an agricultural engineer and you stumble across this podcast, feel free to reach out. If you're a student and you're thinking about agricultural engineering, you can also drop a message on LinkedIn and I'll be happy to answer any questions.
No, thank you very much, Dr. Maharaj. I think one thing I can emphasize is, together with our listeners, we're not done with you. There are several other things that you talk to, such as the amount of work that you have been doing at Ground Truth. And I think, beyond your research, that's one space that we would like to tap into to hear what exactly it is that you've been doing on a day-to-day basis. So please, when we reach out again, please do join us. But I don't know if you have any last words for our listeners, but from myself, thank you very much for your time.
I think, Damien, I'd like to thank you for hosting this podcast and working with SAI and the Royal Academy of Engineering, because I think it's a great initiative to put the work out there. And yeah, anytime you feel like you want to have a chat with me, feel free to send a message or email, and I'll definitely hop on. Because as you know, and even when you and I meet, or you meet any other agricultural engineer, the conversation just flows, and we can, because of how diverse the field is, we can chat about anything from growing food to water to climate to energy to sustainable energy. So I think, yeah, whenever you feel like you want to have a chat with me, feel free to reach out to me. But again, thank you for having me on here. And I think this podcast is a great initiative. And I hope it inspires quite a few people and builds the field of agricultural engineering and makes it even stronger in South Africa.
Well, that was it from Dr. Maharaj, who gave us an overview of the role of agricultural engineers in research. Thank you for tuning into the Agricultural Engineering Podcast. We appreciate your support. Don't forget to review and rate the podcast and share it with family, friends, and colleagues. More information can be found in the description box. We're looking forward to connecting with you in the next episode. For now, stay safe and goodbye.